talking about a few things. I just walked by you. A couple things. If you were to see something like this on the test, you know, looking at this, there's no plus sign, there's no minus sign. We're just multiplying all these things, right? So you can just multiply the numbers, or you can reorder it, whatever you're comfortable with. So 4 times 5 times x to the 5th times x to the negative 5th times y to the 0 times y to the negative 7. Now, I'll make a suggestion. On the test, it doesn't take you that much extra time to just reorder it, and then you have them right next to each other, and you're less likely to make errors, because a lot of you know what you're doing, and then you just, when you start looking around, you'll add something wrong or something. But when you put it in the correct order, where you have the like base by each other, it makes less errors. 4 times 5, 20. Make sure you multiply those. Do not add those. And then right here, when you multiply the same base, you add the exponents. So what's 5 to the negative 5 would be x to the 0. Which is just 1. Which is just 1. Now, I suggest on the test showing your work, so that in case something bad happened, I could give you points. And then right here, we have the same base. When you multiply, you add your exponents. So 0 plus negative 7 is negative 7. So then we have 20, and then you said that whole thing becomes 1. Don't say that's x to the 1. It's not. The whole thing goes away and becomes 1. Now, I see a lot of people do this on the test. They go 20 plus 1. We didn't have any additions, right? Yeah. So you multiply. So 20 times 1 is 20, and then we have y to the negative 7.
Flip it over.
Then flip it over a fraction. So you bring that down to the bottom, and it'll be positive 7. So then I don't want you to write it like that on the test. Write your final answer pretty like 20 over y to the 7.
Because that looks like you're saying the like going to negative 7 equals to x.
Right, right. Does that make sense, everybody? Any questions on that one? None. Okay. Okay. Well, I don't know why, because that's good. That's a good point, but it's not. We'll go over that in a second. Yeah, it shouldn't be hard though. It shouldn't be. So maybe you're just thinking too hard about it. Okay, looking at this one, raise a power to a power. Okay, well first of all, we need to decide if we can if it's breaking the forbidden rule, to just multiply the powers. Is there even a forbidden rule here?
No.
No, because there's no addition or subtraction sign in here. So guys, this is properties of exponents. So raise a power to a power, and you multiply the powers.
I have a question.
Yeah.
So it was like a subtraction or addition problem. What would you do with the negative 2?
Well, you won't see that. Yeah, good question. You'll just split that. But you wouldn't see that. Or you'd flip it over a fraction and then double distribute for future. Yeah. Okay, so we have negative 3 times negative 2, which is positive 6. And then b positive 1/3 times negative 2 would be negative 2/3. Now, if you didn't know how to do that, you type it into your calculator, but you have to use parentheses like this. 1/3 times negative 2 in your calculator. Okay, so then from here, we're not finished. We have to flip anything with a negative exponent. Is a to the 6 connected to this?
It would be a6 over b to the negative 2/3.
To the negative 2/3?
Whatever.
Make sure you don't write negative on accident. Good. A to the 6 over b to the positive 2/3. Good. Yeah. Yeah. So you would flip it and then write a negative on accident. Yeah. Right? Is that what you're saying?
I just took the number next to it down.
Oh, okay. Yeah. Good point. So if we would have had 2b to the negative 2/3, we would not flip the 2 with it. Good point. Yeah. Good point. This would be 2 over b to the positive 2/3. Good point, Riley. I'm glad you brought that up. Okay, let's do another one. Any questions on power to a power? Do not make any errors, like when flipping. Don't write negatives on accident, and then don't bring the number down with it. Okay, so looking at this one, when you divide, then you subtract. But that doesn't work for numbers. Numbers, you'll just ignore that properties of exponents rule and simplify. 9 over 3.
3 over 1.
Good. 3 over 1.
Which is just 3.
Which is just 3 on top, right?
Yeah.
Very important. 3. And then right here we have an x. Do we have any x's down here?
No.
So x is going to be stay where it is. Now what if x would have been on bottom and there's only an x? It doesn't magically float to the top. You leave it where it is, right? Right, everyone?
Yes.
Okay. So then looking at this, we have the same base. We're dividing it, so we subtract our exponents. This is very important. You subtract the top minus the bottom. So y to the negative 3 minus, and then look at the bottom, negative 2.
So that would be change the signs from negative 3 minus plus 2.
Okay, good. So 3y, so we have negative 3, and then you said since we're subtracting negative, you make it a positive. So that's negative 3 plus 2, which
You
is,
get a negative 1. Right.
right. So negative 3 plus 2. So what we really would have had was 3x y to the negative 1, right?
With the y over.
Negative 1, yeah. Okay, flip the y over a fraction, and it becomes positive, but don't write it there, and don't cross it out either. Go off to the side and rewrite it. 3x over y to the first, which is just y, yes?
So, I was taught a different way. Could you just take the bottom y and put it to the top and basically just say that's it?
You would, yeah, because if you brought this up, you would have had positive 2, right? But then we'd use a different property of exponents. You would add, right? Get the same answer. Great. Yeah, you can do that. Absolutely. Okay, any questions on that one? Ask if you do, that's why we're here. Okay, so looking at this one, just quick. Looking at this one, let's simplify it. Is the 3 on bottom? This is where I saw the most errors, and you're going to see some stuff like this on the test. Is 3 on bottom?
Yes.
Is there any other numbers?
Yes.
No other numbers. So we got to leave the 3 where it goes. I saw people when they were simplifying, they floated the 3 to the top. It was on bottom, it needs to stay on bottom. When you divide and you subtract, what's my exponent on x? 1. What's my?
1.
So 1 minus 1 is?
0.
So we'll have x to the 0.
Which is 1.
Are we all okay with what I did? Kind of skipped a little step. And then we have, what's my exponent on y?
1.
So we'll be doing 1 minus 2. So 1 minus 2, negative 1. So we have x to the 0, y to the negative 1 over 3. Okay. Yeah. Yes. When you divide, you subtract. That's why we're subtracting the top exponent from the bottom. Yeah, good question. So then x to the 0 doesn't become x to the 1. Don't say, oh, anything to the 0 power becomes 1. No, the exponent doesn't become 1. The whole thing becomes a 1. So we have 1, and then we have y to the negative 1/3 over 3. We need to flip negative exponents, right?
Yes.
So it'll be 1 over 3y.
Very good. So then you still have the 1 on top. On bottom, you have a 3 and a y to the first, which is just y. Any questions on that one? Did it make sense? Okay.
Is they going to be about just these or?
No, it's going to be everything. I just wanted to go over these because these are where the most errors come in. But we're going to go over them. Okay, continuing. Okay, let's be careful. Let's hurry in quickly. Just like at least write this out. So with this one, we're multiplying, right?
Yes.
Okay, so let's do that and then write it in standard form. Okay, write it in standard form. So once again, start with 2x and distribute that through to each term. 2x times 4x, careful, is what?
8x squared.
Good. So guys, the most common error is people leaving off that square. Does everybody understand why it's squared?
Yes.
Okay. 2x times 4 is? So plus 8x because it was positive 8x, you're right. Now we've distributed 2x here to everything. Don't double dip and start distributing it through underneath too. Move on to 3, negative 3 times 4x.
12.
Negative 12x, very good. And then negative 3 times positive 4.
Negative 12.
Negative 12. So then let's combine like terms and we'll make sure it's in standard form or put it in standard form. Highest degree is x squared. You guys, if you don't have an x squared when you're multiplying polynomials with an x and an x, you've got something wrong. Don't make that error. Okay, so then 8x squared, no other x squared. 8x minus 12x's is negative 4x's, right?
Yeah.
Negative 4x's, and then we have minus 12. Now look at this one. It's already in standard form. When standard form means the highest degree, then the next highest degree, then the next. You know, when I say degree, I'm talking exponent.
Oh.
Yeah.
I thought it was number.
Nope, it's only,
That's what I thought too.
yeah. So we'll make sure to have to go over that one day in the future. What? So this is the highest degree. You only look at that. This up front doesn't even matter.
So they're just ones, aren't they?
For the
That's
other
a one.
two, does it matter which one you have there? So
What was that?
For the other two, does it matter which one's first?
Yes, because this is x to the 1, right? And that's higher than x to the 0, because x to the 0 is 1. There's no 0. I mean, there's, yeah. Does that make sense?
So pretty much it'll always, most of the cases,
It'll always be x
it'll go
squared,
x squared,
and
then
then
x, then the number.
Yes. That would be standard form.
Unless you
Now I
have
got it.
x and y, then be x and
Right. Okay.
Square x.
Let's do this one.
One more
5n plus 2 squared. Can we just square this?
No.
No, because of the plus sign, we know that would be breaking the forbidden rule. So we'll quickly rewrite this as 5n plus 2 times 5n plus 2. Then from here, we're just multiplying polynomials, but very carefully. 5n times 5n is 25n what? N squared. Do not miss that squared. Oh, if any of you miss that, now that you're here in the morning, I'm going to beat you. 5n times 2 is positive 10n. And then you go underneath. Now we're done with that. We just distributed that. We're going to start with positive 2. So positive 10n again. And then 2 times 2 is 4. And then you'll combine like terms. So 25n squared plus 20n's, right?
Yes.
And then plus 4. Now don't make the error if you have two negatives there to just assume they cancel out. Actually add them up.
No, you're probably done with polynomials prior to standard form.
Because of how they're set up, yes. Yes. They have.
One more problem with standard form. That's all out.
Okay, let me insert then. Insert blank page. Okay, let's say that it was backwards, like 2 minus 2x squared. Can we just square that and square that? No, because of the subtraction sign. That'd be breaking the forbidden rule. So 2 minus 2x times 2 minus 2x. Now from here, we'll double distribute. Focus on 2. 2 times 2 is
4.
2 times negative 2x.
4x.
Negative 4x.
Good. Negative 4x. We distributed 2 through to everything. Negative 2x is times 2.
Negative 4x.
Negative 4x's, and then negative 2x's times negative 2x's. Careful.
4x squared.
Good. Positive 4x squared. Let's combine like terms before we put it in standard form. So we have 4, and then negative 4 minus 4 more is negative 8x's, and then plus 4x squared. So now we need to write it in. Yeah, you just flip it because it happens to be. So it was positive 4x squared, right?
Yes.
It needs to stay positive. Positive 4x squared. It was negative 8x. It needs to stay negative. So minus 8x. Does everybody see why it's minus 8x?
Yeah.
Plus 4.
Plus.
Okay, good. Okay, yeah. Okay. That's all you need to be here for, then you can feel free to lose. Okay, so remember with dilations, guys, this is important. With dilations, you're going to take all your xy points at the vertices. So if you have a triangle, you'll take that point, and you'll multiply all of them by the factor, right? Yes.
So like coefficient and stuff, are we gonna have that?
Yes. Yep, you'll definitely have paper for that. Okay, so any questions on dilations and how they work? You'll just take all your xy points and multiply them and replot the points, right?
Or divide, right?
Yeah, you'll always be multiplying because it'll be like multiply by 0.5, you just multiply by 0.5. If it was 1/2, multiply by 1/2, which is divide by 2. Same thing as multiply by 1/2. Is that what you mean? No, because we're technically, if you think about it, if you take something and multiply it by 1/3, you're dividing it by 3, right?
Okay.
So we're just always going to multiply. What?
How do we put that into a character?
You'll go like this. Like for example, let's say your point was 3, 2, and you needed to multiply that by 1/3. You'll just multiply 3 by 1/3, right? So you'll type in 3 in your calculator, and you'll hit times, and then in parentheses do 1 divided by 3. It's the divide sign.
That's madness.
Yeah.
Cool.
Yes.
So on the review, that was only 1/7.5. But there's no 7+5.
Oh, hey, that's a good point. I'm glad you brought that up. Okay, so listen to this. If on the test you dilate something or translate it or something and it moves off of the graph, just go with it. Because you still just draw it in if you need to. Yeah. Does that make sense?
Yeah, I was like, wait, is that right? And then I did overlap it like,
Oh, crap.
Okay, so remember that reflections, we can reflect across the x-axis. So this is the x-axis, guys. So if you have a heart, then it would be a heart reflected. Those points will map evenly, right? No, I'm not letting you use that. If you're going to reflect across the y-axis, this heart would reflect over here, right? They map evenly across the y-axis. And then if we're going to take this heart and reflect it across the y equals x-axis, that's this green line, you would fold it like a sandwich and it would be somewhere kind of down here. I can't draw perfectly backwards.
Wouldn't it be upside down?
It'd be upside
No.
down.
Well, it'd be more on a slant. So I just can't, didn't draw very good sideways. Because think about it, if you took it and sandwiched this over,
Oh yeah.
it'd kind of be like that. It wasn't a very good drawing there. Yeah.
So I tell you.
Okay, translations. Guys, if you see translations like this, you have to know what it means. So X, Y, so if we have a translation and it says it like this, that means right 2 and down 5. Does everybody understand how translations work with those?
Yes.
Yeah, I'm totally gonna sit
Oh,
here
wait, so.
You're gonna what?
today. Sit here today.
No, you're gonna sit in your regular
Hey,
seat.
can I sit right here for the test?
No, you're gonna sit in your regular seat.
This is.
Hey, don't waste this time, or
Yeah.
people are gonna hate you. Okay, everybody listen. Does everybody understand? Left and right. That's your shift, left and right. So if it would have been X minus 2, we would go left 2. You take every point, every vertice, once you've done whatever, or take it and you'd shift it left 2, if it was minus 2, and then Y minus 5, this would be down 5. If it was Y plus 5, it would be up 5. So does everybody understand? This is your shift left and right, this is your shift up and down.
Yeah.
We're all okay with that.
Why are you recording this one?
Because I want to post it for people.
Okay.
Don't ask dumb questions, guys. People don't waste people's time, or don't come to these early morning reviews. I'm sorry, but I feel bad for people that are here. What?
If you post these videos, watchable for
That has nothing to do with the review, guys. I'm gonna kick you out because really people are here to review. Okay, so let's keep it with the review. Okay, looking at this, guys, we have 2 parallel lines and a transversal. If I ask you to solve for X and state what angle relationship, let's look at this one. This 30 is kind of coming over this line because I didn't draw it small enough, but it is this angle. So looking at this one, what's a true statement to say?
2x equals.
2x equals 3x plus 30. Now, how'd you know it was 2x is equal to 3x plus 30? They're corresponding angles. Does everybody see how they're on the same side of the transversal? It's on top of the parallel line and it's on top of the parallel line. Or however you look at it. If you see them both on bottom, then that's the same thing, right?
Yeah.
So we would have to say, though, on the text, by corresponding angles.
So that's all you have to put is 5 corresponding.
Yeah. Yep, but then we'd solve for x, so I would subtract 3x from both sides. So we would have negative x is equal to 30, right?
Yes.
And then when you get this negative gone, well, that's like dividing both sides by -1 will take care of that. So we have x is equal to -30. Does that make sense, everyone?
Yeah.
Okay, make sure you say on the test how you knew what to do. So let's look at this one. 10x and 3x plus 2, what's a true statement?
10x is equal to 3x plus 2.
10x is equal to 3x plus 2 is equal to, that's kind of small, 3x plus 2, how do you know they were equal?
Vertical angles.
Good, vertical angles.
Do you have to go by vertical or you just go vertical?
Vertical angles.
I'm good at these ones.
Okay, so then you'd solve for x. I'm not going to finish that one. Is that okay?
Yeah.
Everyone? Okay. What about this one? 7x and then 3x plus 2. What's the true statement?
3x plus 2 is equal to 180.
So 7x plus 3x plus 2 is equal to 180. Why do you say that?
Because the 2 added together are equal to 180.
Why?
So we want to do there.
Okay, good. That's what I'm looking for. Look, this is a straight line angle. Because guess what? If you said consecutive interior, that would be wrong, right? They're not consecutive interior because that would be this angle and this angle. So this one would the only answer that would be acceptable is straight line angle. Good, Alex. Yes, I'm Tyler.
So the line this way is straight, but what if both those lines are straight too, and it showed that they were straight, but they all come close?
So you mean if, well, right here, this is a straight line?
Yeah.
That would also add up to 180. And think about it, this would be, if this is 3x, this is also 3x plus 2, right? Due to vertical angles. So yeah, it would be the same statement. This plus this equals 180. Does that make sense?
Are we going to stumble across, are we going to stumble across the problems like these ones, but we have to find all the things?
Probably not. Okay, let's practice domain and range. Here we go. Quick. Domain and range. So looking at this one, domain is x values. So how far left and right, this is our x-axis. How far left and right? So-
-6 to +5.
-6 to +5. Okay, so I'm gonna write that -6 to +5. But if you stop there, you're not gonna get the right answer.
It would be one
Or
part
be
Parentheses, due to the open circle, didn't actually touch down at 6. And so at 5 it's a closed circle, so it's a bracket. Now range is y values. Now this is talking the y-axis. How far down and up does it reach on the y-axis?
Negative.
Negative.
-7.
-7.
+6.
+6.
Doesn't include -6.
And it doesn't include -7
7.
because of the open circle. And it grabs. Any questions on domain and range? Okay, what about this one? This one's a little bit trickier, domain and range. Okay, ready? What if I drew this?
Oh, okay.
What's our domain on this one?
So if you a negative or a
Where's my function growing on the x-axis to the left?
-4 to infinity.
No,
negative 4
On X,
on the x-axis for domain is x.
Oh,
Negative 4 to 4.
-6.
it'd be 7.
No,
negative 7.
no, no, none of those. So let me tell you, okay? Everybody look with your eyes. Does it matter that it's growing up for domain?
No.
Okay, I'm talking, no, for domain it doesn't.
Oh,
So for left and right, the function's growing this way forever, isn't it? It's going to keep going. So it's going to negative infinity. Where's it going to the right? Positive infinity.
People would say that.
No, I didn't hear anyone say that.
I think I heard someone say it.
I didn't hear it. You said 4.
No,
Yes, you did. Well, I didn't hear it. So I apologize. Hey, let's look at range. Does everybody understand why it's negative infinity to positive infinity?
The arrows?
You gotta look with your eyes in the right spot. So it doesn't matter that it's growing up. Doesn't matter at all. Does that make sense? So look to the left, it's growing this way forever, right? You see the arrows pointing?
Oh.
So it's growing this way forever. And then this way it's growing right forever. Yeah.
So if it doesn't have a dot or a point, I guess it's not open or closed, it just has the arrows, it would be infinity.
Yes.
You kind of
Yes.
have to look at.
So let's do range now. Let's do range now, guys. Range is how far up and down. So where does the function start?
-4 to infinity.
-4, and it's growing to
Infinity.
positive infinity. Did it include -4? Touchdown right at 4 on this one, right?
Yes, so that's a bracket.
And then infinity always gets parentheses.
Yeah.
Do we need another one that looks a little bit like this? 'Cause there's domain.
Yes.
Yes, most people have a hard time with domain. Yeah.
I think you're confusing people on the X one because you said that don't look at the arrow pointing up to.
It doesn't matter that the arrows are pointing up at all.
Yeah, but you said
They're
not
pointing
to
this
look
way.
at it, but you actually need to look at it to be able to tell it.
Well, I didn't mean not look at them, but I meant don't look that the arrows are pointing up. It doesn't matter.
None of
Left and right, where are they going to? Yeah.
Right.
Yeah.
Because the slowly go upwards, they are going.
Yeah, they're going to go upwards. You're right. But for domain, that doesn't matter. We're looking left and right where the arrow's growing. Should I have said that? Does that make sense?
Yeah.
Okay.
So somehow we figured out like what infinity was, like would we put bracket around it still or would
Yeah, there's just, infinity is not an actual number. It's like a place. It's like a really, because it's just getting infinitely larger, infinitely smaller numbers. Like it never stops. Does that make sense? Yeah. Hey, what if you saw something like this? What if you saw something like this?
oh
Oh, good
I think that might
Miss.
know.
Still
What's
has
the domain?
domain?
The domain
Negative
is negative infinity.
Negative infinity to positive infinity. And what's our range on this one?
Oh, let me look at the
Negative infinity to positive infinity.
Good.
No.
It's growing down to negative infinity and up to positive infinity.
Oh, okay.
Yeah, that one's tricky.
I thought it was like negative 1 or something because there was like,
Yeah, so that's why I did this one is because it can be tricky. Does everybody understand?
yes, I
Okay.
guess now.
Okay, moving on. These ones you have to know how to do, guys. So here we go.
Oh,
So much common errors. Watch this one, Alex. Here we go. It says find a statement for area and perimeter. So here's my picture. We know the area is equal to 10. Okay, well let's write a statement for area and perimeter. So this is something you have to know, yeah.
We did split the surface because like no area
Yeah. So perimeter is you're gonna add up all the outside. So if you don't want to do it that one advanced way, you don't need to. So this is 3x minus 2 as well, right?
Yeah.
This is the same length as this, and this is 2x. So for perimeter, we'll add up all the outside. So we'll have 3x minus 2 plus 2x plus 3x minus 2 plus 2x.
So for the
And that's your perimeter. Combine like terms.
okay. For the test, are we going down to solve the perimeter?
Or the area, one or the other.
About x.
That's, you'd have to solve for x using area or perimeter depending on what you're given. So in this one, I happen to be given area. So we plug it into the area formula, not perimeter, right?
Yeah.
Okay, but let's go through area, because this is actually where the most common errors come in. Most of you missed this on the quiz. So area is length times width, right?
Yes.
Length is 3x minus 2. Now guess what most of you did? You wrote times 2x. It is. Area is length times width.
Oh.
But guess what you forgot? So important. Hey, watch this, because you're going to miss it since you're not watching.
I'm here for that.
No, you missed this on the quiz. What? Look. So area is length times width. Most of you wrote that, and then you didn't, because you didn't write in your parentheses, you didn't double distribute, and you have to double distribute.
Okay. That makes sense.
So you have to write those parentheses in, because, so now 2x times 3x is
6x.
6x squared. And then 2x times negative 2?
How do you square negative 4?
Negative 4x. Because 2x times 3x, x times x is x squared.
Multiplying an x to another x, you square it.
Right.
Because you're multiplying like terms.
Yeah, any questions? Now, we would go through this one we couldn't do. In this class, we haven't learned how to solve quadratics yet. But area is equal to 10, so 10 is equal to that, right?
Yes.
And then you solve for x. Now, this one, you aren't going to see two x's because we haven't learned how to solve quadratics yet in this class.
We can just. Never mind.
You wouldn't. That's a common error for secondary 3 students to make at the beginning of the year, but you wouldn't. But we'll learn this in the next couple weeks.
That's not gonna be fun.
So
It is fun.
put that other answer.
So this was, but you would solve for x. This was, okay, let me erase one thing and then we'll redo this problem, like on solving. Let's say that was just 2 instead of 2x.
Okay.
Then we would have had length times width, like this, right? Everybody back to here. Then we can solve this one.
6x.
So this would have been 6x
Negative 4.
minus 4. Now make sure you put those things in parentheses. So now we have 10 is equal to 6x minus 4. Now could we solve for x?
Yeah, that's right.
Add 4 divided by 6.
So 14 divided by 6.
Right. Is a decimal. Yeah. Or I probably want the most simplified. I don't know. Yeah.
So if it was infinite, you probably could say that it's sign off with it, or we could just.
Back to domain.
No.
Oh, with this. I don't know where infinity won't come in with this.
So like if you have like 1.1111.
Oh, you mean like if the decimal? Oh, round. It'll say on there like if it's a big. If we're gonna be dealing with decimals like 1.11237 whatever. Write out the whole decimal, but I'll say like round to the nearest tenths if there's ever a need for that.
About if it's like repeating.
Like on this one.
Wait.
You're not gonna see that.
33333.
Okay, yeah. So you would do 2.33. That would work.
What is that?
But actually, no, you wouldn't. Change it back to a fraction. That's what I'd want as the answer.
Oh.
Yeah, good question. Okay,
And you would get.
looking at this, right, and I'd want that answer. That's perfect, because that's exact. Does that make sense? Okay, let's write a true statement. We won't solve for x. What would a true statement be in this one?
30 plus x plus
30 plus x plus 2
plus 3x times 4 is equal to 180.
is equal to 180. Now, guys, the reason that is because all three angles of a triangle must add up to be 180, right?
Yes.
So set up a true statement and then combine like terms and then solve for x. Are we all okay with that?
Yes.
But isn't this a equal on the track?
It looks like it. We never draw it to scale necessarily.
Yeah.
You need the dills.
Okay, what about this one?
It'd be nice.
Yeah, good. If they had the dills, then you could.
2x plus x is equal to 180.
Wait, what did you say?
90 plus.
Why'd you say 90?
Because the square difference.
That's a 90-degree angle. Okay, so 90 plus
X plus
Plus
2x is equal to 180.
is is equal to 180 due to the fact that all three angles of a triangle add up to be 180. Good. So then we combine like terms.
You know the game where we had that problem and I did that and I just divided yeah.
Yes.
I totally didn't even know that little bill. I was just going with it.
Oh, really? But you know now that in the future you can't assume that, right?
Yeah.
Okay, good.
So
Good. Yeah.
So, could you just put x plus 2x is 90 because the 90 not right there?
Not necessarily because, oh, I see what you're saying. So, Tyler, I won't say that to everybody to confuse them. You could, but only because, no. Well, that is true actually. Because you're saying, you know, that since we only have 90 degrees left, right, that this is 90, yes. Everyone else ignore that because that will confuse you. Yeah, good, Tyler. Yeah, that would work.
Cool, you're smart.
Yeah, and that would work. But it would be, yeah, that makes sense. But I would always, I'd be careful when doing that.
So it'd be 30. X equals 30.
So if you do 2 times 30.
Yeah, it would be. And I just did it in my head, both of them, and they both come out to be 30. Yeah.
And so it'd be 60, 30.
Yes. Okay. Solve for P. Solve for P. Look at this one really quick. So over here on the left, we have 10 is equal to 3 times all that stuff. We've got to distribute. 3 times P is
3P minus 12.
minus 12, and then solve for P. So add 12.
24 equals 3p divided that by 12.
That's what I forced it to.
Almost. It's not.
Okay, so you guys know how to solve for P.
Yeah.
Okay, 7.3, and I want fractions, so P is equal to
22 over 3.
yeah, 22 over 3.
Wait,
Yeah,
Pretty
it's
sure we can all
simple.
how
add
do
this.
we put fractions or like how do we make fractions out of
Because once you get a decimal answer, you hit the math key and then hit enter, enter. Math, enter, enter. Can you remember that?
It's out.
So, will there ever be a time where it's like there's a number that is like they're even so you can simplify them,
Yes.
but like you cannot like make them into a formula?
Yeah, that's a good question. So Tyler said, what if we got an answer like this? For example, let's say we got P is equal to, let's go like 24 over, let's do 24 over 16. What do they both divide by?
2.
They both divide by 2, but if we did, okay, so this will, now if you had a calculator, it'll do it for you. You'll do 24 divided by 16, change it back into a fraction, and we'll put it in the most simplified answer. They both divide by 4, is the greatest
You
thing.
can do 6.
that make sense?
Couldn't you? No.
No, they both divide by 4, and this becomes 8, this divides by 4, and oh wait, no, that doesn't. 3 over 2. They both divide by 8 is the greatest thing. So that's why you would just use your calculator. See, she did. She put 24 divided by 16, changed it back to a fraction, and got what? 8 over
3 over 2.
Yeah, 3 over 2. That's right. 3 over 2.
Okay.
Good question, Tyler. Okay, any questions from the review?
No, man.
Anyone?
Nope.
I think that's why I need a calculator.
Are you feeling more confident?
Oh heck yeah. I'm on it like
I'm
Okay.
gonna study.
Have a good day.
Thank you.
Thank you for coming.